about economic and optimal power flow in PowerFactory for power systems. For this purpose, we can make this power system. Here we have load. If you double click, here we just put a 10 megawatts load here. And here we have two lines. One line is 50 kilometer and the resistance is 0.01, reactance is 0.01, and it's 10.5 kilovolt. The bus bars is also 10.5 kilovolts both, and this line is also 10 kilometer, and the line is exactly same line type. So it's 10 kilometer, this is 50 kilometer. Here we have 46 MW generator is selected from the library of PowerFactory. Easily you can select the same from the library, 46 MW. And this one is the 4.9 MW. You can also select that from the library of the PowerFactory. It's almost there. So this is the power system that we have. You can also make it. And normally this is 10 kilometer, this is 50 kilometer, and if we make one power flow, it doesn't care about this is 10, this is 50, and this is closer to load, so most of the power should be generated by this because the losses will be less. But if you make a load flow here, it doesn't care. So here almost all of the power come from here to this, nothing from here. And yeah, but here we have option. If we click on this toolbox, here we have optimal power flow, click. Then here we have this option, optimal power flow. If we click on that, here we have this window, and on this window we will have the power flow, but in this case we have some objective function, and the objective function, it can be different things. For example, it can be minimization of the cost, minimization of the losses. For example, here if we click on the execute, you can see because this generator is much closer to the load than this one is 10 kilometer, the losses will be less. So most of the power, 4.7 MW, because this is 4.9 MW, is generated by this generator going to this, and the rest come from here, and is some optimal one. If we go here, we have also minimization of the cost. For doing that, if you double click on the generator, here we have optimal power flow option. And normally is empty. So here you should check active power and reactive power, minimum and maximum. Minimum can be 0, for example, and the maximum is 4.9. Here we have operating cost. For operating cost, normally we have a curve, megawatts per USD per hour. You can make this curve, for example, for 0.5 megawatts, the cost is 1 USD, and for 1 megawatt, the cost is 2. So this is direct line. For this is also same, but the value is different. For example, 0.5 is 4, 1 is 8, so it's more expensive. If we make optimal power flow by minimization of the cost, you can see also here most of the power come from here because it's much cheaper, and the rest coming from here. So here we have two power flow. This one is just normal power flow without considering anything, and here we have optimization of power flow by considering the losses or cost.